have two sequences, and we want to determine if the sequences are geometric. And if so, then we want to find an expression for a sub n and determine the eighth term in the sequence. So first we need to ask ourselves, what's the pattern to go from one term to the next in this sequence? So from 5 to 15 and then from 15 to 45, it appears that we are multiplying by 3. And you can check 45 times 3 indeed is 135. So yes, this appears to be a geometric sequence of numbers because we have a common ratio, and that ratio is 3. So once we know the sequence is geometric, then we can use our general rule, which is a sub n is equal to a sub 1, the first term, times r raised to the n minus 1 power. And since we know the first term is 5, as well as the common difference, which is 3, then we have a nice formula here for the nth term. In other words, this is an expression for a sub n, which will get us any term that we want in this sequence. So then we can use this general formula to find the eighth term, which would be a sub 8. So this just requires that we substitute in 8 for n. So we'll be computing 5 times 3 raised to the 7th power. And it's okay to get out your calculator since this is going to be a pretty large number. And 5 times 3 to the 7th power is 10,935. So this means that if we continued to multiply by 3 repetitively until we got to the eighth term, that eighth term would be 10,935. So a sub 8 is equal to 10,935. So let's look at the second example here. And again, let's look and see if there is a consistent pattern. So from 36 to negative 12, and then from negative 12 to 4, it looks like we are dividing by negative 3. But remember, dividing by negative 3 is the same as multiplying by negative 1/3. So it appears we are multiplying by negative 1/3 repetitively. If we check that, from 4 to negative 4/3, sure enough, we could multiply 4 times negative 1/3 to get negative 4/3, and it would work one more time to get to 4/9. So this is another geometric sequence of numbers, and this time our r value is negative 1/3. So utilizing that general rule again, or our general formula, a sub n is equal to the first term, which is 36, times the r value, the common ratio, which is negative 1/3, raised to the n minus 1 power. So this would be our expression for a sub n. And then we can use this expression to find the eighth term. So 36 times negative 1/3 raised to the 8 minus 1 power. In other words, we'll be raising negative 1/3 to the 7th power. And while you can type that in your calculator and get a decimal, I'm going to go ahead and recognize that if we have negative 1/3 to the 7th power, we are really raising the negative 1 to the 7th power, as well as the denominator, which is 3 to the 7th power. So I'll end up with a negative times the 36, which will be negative 36. 3 to the 7th power is 2,187. And that fraction will certainly simplify. That simplifies to negative 4 divided by 243. And when at all possible, we want to go ahead and try to get an exact answer rather than a decimal approximation. So this would be an exact value for the eighth term in this geometric sequence.